Every single time you send an email or watch a video or just browse a website, you're plugging into this incredible invisible system that connects our entire world. That system is IP routing, and it's how tiny little packets of your data can zip across the globe in milliseconds. So let's pull back the curtain and actually see how this amazing journey happens. Have you ever really thought about it? How does your computer, right here, talk to a server that's thousands of miles away? You might think it's a straight shot, but nope. It's actually a really complex, super fast journey with a whole bunch of stops along the way. So how does that piece of data get from your laptop in London to a server in Tokyo? Let's break it down. So, to really wrap our heads around routing, we first have to get why it was even invented. I want you to picture the internet not as one big happy web, but more like a huge ocean that's just dotted with countless separate islands. Think about it. Your home Wi-Fi, the network at your office, even the network at a coffee shop, each of these is its own little local area network, a LAN. And on their own, they're completely cut off from each other. The devices inside can chat all day long, but they have no way to reach the outside world. They are, for all intents and purposes, digital islands. So how do we connect all these islands? Well, we need a special kind of navigator, right? A device whose whole job is to build bridges between these networks. And that brings us to the hero of our story, the router. Okay, so this is the absolute core of it all. IP routing is just the process of getting a data packet from a device on one network over to a device on a completely different network. That's it. And without a router, that connection is literally impossible. A great way to think about a router is like a ferry captain. The captain doesn't need to know every single person living on each island. They just need to know which island they're going to. As one of our sources puts it, routers don't really care about hosts. They only care about networks and the best path to each network. All right, so we know the router's job is to forward these packets between networks, but how in the world does it know which way to go? It needs a map, and not just any old map. It needs a very special, incredibly precise digital map. And this is the million-dollar question, right? When your little data packet shows up at the router's doorstep, the router has to decide in a fraction of a second where to send it next. It can't just guess. It needs instructions. The answer is something called the routing table. Seriously, just think of it as the router's internal GPS. This table, this map of the internetwork, has all the information the router needs to find any other network it knows about. Now, to build this map, a router has to know a few key things. First off, where's the final destination? It also has to know its immediate neighbors, the other routers it can talk to directly. From them, it learns about all the possible routes to get somewhere. And here's the most critical part. It has to figure out the single best route and, on top of that, constantly keep that information up to date as the network changes. Okay, so how does a router actually get this map in the first place? Well, it turns out there are two totally different ways to do it. Think of it as the difference between giving someone a hand-drawn map versus a live, updating GPS on your phone. So on one hand, you've got static routing. That's our hand-drawn map. A network admin has to literally manually type in every single route. It can be fast, sure, and it's secure for really small networks that never change, but it's also a ton of work, and the second anything changes, the whole map is wrong and everything breaks. On the other hand, we have dynamic routing, the live GPS. This is where routers are constantly talking to each other, automatically sharing updates about the best paths and any changes on the network. This amazing adaptability, well, that's the foundation of the entire modern internet. So you can see why this map, this routing table, has to be accurate. It's absolutely crucial. Because if a packet arrives and its destination network isn't in that table, the router has no idea what to do. It won't send out a search party. As our source material puts it so bluntly, the router just discards the packet. Period. The journey ends right then and there. Okay, so now that we get the stakes, let's actually follow a single packet on its journey. Let's say here we have host A, that's our computer, and it wants to send a message to host B, which lives on a totally different network. Because host B is on another network, host A sends the packet to its local router. This is the first stop. The router gets the packet, takes one look at the destination IP address, and immediately consults its routing table, its map, to find the best way to get to host B's network. And the routing table has the answer. It tells the router, hey, to get to that network, you need to send this packet to the next router in the chain. The router then zips the packet over a long-distance connection, one step closer to where it's going. And this process, hop to a router, check the map, forward it on, that can happen dozens of times for just one packet. And finally, After a series of these little hops, the packet arrives at the router that's connected to host B's local network. That router delivers it, and just like that, the journey is complete. And this all happens in the blink of an eye. It's incredible. So, what's the big takeaway here? Why does this whole system of maps and navigators matter so much? Well, it's all about creating a network that is alive, a network that can actually adapt to change.
This is the real magic. Because routers are constantly talking to each other using dynamic routing, the internet can literally heal itself. If a major fiber optic cable gets cut between two cities, the routers automatically figure it out, find a new best path around the problem, and update their maps, all within seconds. This is also what allows the internet to grow to this insane scale. Trying to manage today's internet with static, hand-drawn maps, it'd be like trying to hand-draw a perfect up-to-the-second map of every single car on every road on Earth. It's just not possible. Dynamic routing makes it all work.
And that leaves us with a pretty fascinating thought. This entire global system is built on routers trusting the information they get from their neighbors. They just assume everyone is playing nice and trying to find the best path. So what happens to our data and to the internet itself when one of those routers decides to lie?